Hi everyone, today we'll be doing question 107 LeetCode called binary tree level order traversal 2. So we're given a binary tree, this time we want the bottom up level traversal of its nodes. So left to right and level by level. So in this case we're given this and we should get 15, 7, 9, 20, and 3. So this is a follow-up of the first question binary tree level order traversal. I'm going to be using a similar method to that question, so if you're confused at any point in this video, please refer to that video first. Cool, so let's get started. So first off, let's have our result on our answers. And second off, because we need to go to the bottom of the tree, let's find the max depth of this tree. So we can say function max depth of the root and level. If the root is null, we return the level, else we return the max between the two recursive calls. If any of this confuses you, this is another question on LeetCode called maximum depth of binary tree. I have a video for it, please refer to it if any part of it is confusing. But the basic idea is we're gonna do a recursive call on the left and right subtree, and every single time we go down a level, we're gonna add 1, and we're just gonna return the max between the two. Cool. Then let's do our level traversal now. So level traversal using a node, and I'll call this the max depth. So the node is null, we just return. And here's where the similarities come from the previous question. If the result of the max depth is empty, we make it a empty array. And then we push in our current node value. Then when we go left or right, the idea is since we start at the max depth, which is technically 3, which is going to be the last part of the array, every single time we go down, we're going to be subtracting 1 from the max depth. So since 3 is quote-unquote the max depth in a bottom-up traversal, every single time we go down, we're going to the more shallow parts of the tree. So you can say traversal node left with max depth minus 1, and level traversal right max depth minus 1. So once again, because 3 is considered the max depth in our binary tree, every single time we go down a level, we're going to get more shallow, aka those will come first in our array. So at the end, we just have to invoke this. So we can say level traversal with the root, as well as let's invoke our max depth function with the root, as well as -1. The reason why we do -1 and not 0 here is because the max depth function will return us 3, which means that this would be at index 3, index 2, at index 1. But since we want this at index 0, we have to move everything down 1. So we should have this at index 2, 1, and 0. So that's why this is a thing. And finally, we just return our result at the end. So let's see if this works. Works just fine, and works just fine. Cool. So runtime. Finding the max depth is just DFS, which is O of n, and then doing a level traversal is also O of n. So this is technically O of n plus n, which is still just O of n. So this is just O of n where n is the number of nodes in our binary tree. Cool. So with that, I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.